century ago. As seen from the Earth, a star exploded near the center of the Milky Way galaxy. Astronomers think that this object represents one of the last stars to undergo a supernova explosion in our galaxy. Today, the object is known as G1.9+0.3. In addition to its relative timeliness, G1.9+0.3 is also of interest to astronomers because it belongs to a special subset of supernovas called Type 1a. These are important supernovas because astronomers think they explode with a consistent brightness, which allows them to be used as cosmic distance markers. Type 1a supernovas were used to determine that the expansion of the universe was accelerating. As important as these objects are, astronomers are still unsure exactly what causes them. There is a consensus that Type 1a's occur when a white dwarf undergoes a thermonuclear explosion. But what triggers that detonation? The two main candidates are either the accumulation of material on a white dwarf's surface from a companion star, or the merger of two white dwarfs.
It really burned in. Damn. Boy.
A new study using X-ray data from Chandra and radio data from the Very Large Array reveals that at least one Type 1a was caused by the merger of two white dwarfs. This supernova left behind the remnant called G1.9+0.3. The researchers determined this by examining how the blast wave from the explosion interacts with the material surrounding the doomed star. Clues from this interaction led them to conclude that a white dwarf merger was responsible for this particular stellar explosion. While this doesn't mean that all Type 1a supernovas are caused by white dwarf mergers, it does imply that at least some of them are. It's important to determine exactly what the trigger mechanism or mechanisms for Type 1a's are, since that could affect how they are used in the critical measurements of vast distances across the universe.